Problem number 26. Let's evaluate this limit right here. If we quote-unquote try to plug in for x is equal to 0 here, we'd end up with 0 to the 1/2 times natural log of 0, or this is like a 0 times infinity. You know, limit as x goes to 0 from the right of natural log of x is negative infinity. So this should be showing us, I should put this in quotes because we can't actually write natural log of 0, but it's illustrating here that we're coming up with a 0 times infinity in determinate form. Okay, so where do we go from here? In determinate form, we should be thinking about applying L'Hopital's rule, but L'Hopital's rule only applies if we have 0 over 0 or infinity over infinity. So what do we do instead here? We need to manipulate this. We need to manipulate this so that we have 0 over 0 or infinity over infinity. And what I'm going to do is I'm going to, instead of multiplying by x to the 1/2, I'm going to divide by x to the negative 1/2. So x to the 1/2 is equal to 1 over x to the negative 1/2. And now at this point, this is going to be infinity over infinity in determinate form, so L'Hopital's rule applies. And so we take derivative of the top and the bottom. So the derivative of the top is 1 over x. The derivative of the bottom is negative 1/2 x to the negative 1/2 power. Oh, sorry, x to the negative 3/2 power. There we go. Okay, and so let's try to rearrange this. Limit as x goes to 0 from the right of 1 over x times dividing by negative 1/2 is the same thing as multiplying by negative 2. Dividing by x to the negative 3/2 is the same thing as multiplying by x to the 3/2. And so this becomes, the limit as x goes to 0 from the right of negative 2 times x to the 3/2 over x is x to the 1/2. And here we can safely plug in x is equal to 0 to get 0 here.